Please subscribe and tap the bell icon.
Exercise 1C. This is first bit, first question. We need to find the domains of the following real valued functions. F of x is given as 1 by x square minus 1 into x plus 3. Now we need to find the domain of this function. So domain is nothing but the input data. So what are the input values we can put for this? This function is defined when the denominator is not equals to 0. So x square minus 1 into x plus 3 will be, this should not be equals to 0. If this is equals to 0, then my function will be of the form 1 by 0, which is not defined. So this will be not defined. X square minus 1 into x plus 3 should not be equals to 0. This is x minus 1 into x plus 1 into x plus 3 should not be equals to 0. That implies x should not be equals to 1, or x should not be equals to minus 1, and x should not be equals to minus 3. Here instead of r I can use and. So all this x value should not be equals to 1, minus 1 and minus 3, except for these three values. For all the other real valued functions, the function, for all the real valued numbers, the function is defined. So domain equals to r minus, subtract this 1, minus 1 and minus 3 from the real number set. So for this set, the function is defined. Second question is f of x equals to 2x square minus 5x plus 7 by x minus 1 into x minus 2 into x minus 3. Similarly, here the denominator should not be equals to 0. So x minus 1 into x minus 2 into x minus 3 should not be equals to 0. That implies x should not be equals to 1, and x should not be equals to 2, and x should not be equals to 3. So the domain will be real number set minus 1, 2, 3 values. If my domain is 1 here, so 1 minus 1 will be 0. If my domain is 2, 2 minus 2 will be 0. And if it's 3, 3 minus 3 equals to 0. So except for these three values, for every other values, the function is defined. Third one is f of x equals to 1 by log of 2 minus x. Now this is defined only when 2 minus x is more than 0. It should not be equals to 0. Only if it is more than 0, then it is defined. Nothing but if I multiply minus, x minus 2 will be less than 0. Sign changes here. So x should be less than 2. X should be less than 2. Now for all the values from minus infinity to 2, the function is defined, but we know that log 1 equals to 0. Log of 1 equals to 0. Now log 1 is falling in this domain. If log 1 is 0, then it is of the form 1 by 0, which is not defined. So from this set minus infinity to 2, I should subtract the 1 value here. Now this will be our required domain. Next is fourth one. F of x is given as mod of x minus 3. Now here x can be any real value here. This function is defined for all the real number set. And fifth one is f of x equals to square root of 4x minus x square. Square root functions are defined only for the positive numbers. That implies 4x minus x square should be more than 0, or even if it is 0, there is no problem. So it is more than or equals to 0. If I take out x common, x into 4 minus x should be less than or equals to 0. Multiplying minus on both sides, x into x minus 4 will be less than or equals to 0. So x should lie between 0 less than or equals to x less than or equals to 4. So this is the domain now. Domain equals to open intervals 0, 4. Sixth one, f of x is given as 1 by root 1 minus x square. Again, in this you have the square root function, so 1 minus x square should be more than 0. But here, unlike the previous case, this 1 minus x square should not be equals to 0. If it is 0, then it will be in the 1 by 0 form, which is not determined. 1 minus x into 1 plus x should be more than 0. If I multiply minus x minus 1 into this, I can write it as x plus 1 should be less than 0. So minus 1 less than x less than 1. Domain equals to minus 1 to 1. So we need to put the open brackets. This is the domain. Seventh one, f of x is given as 3 power x by x plus 1. Here x can be any value except that denominator x plus 1 should not be equals to 0. So x is not equals to minus 1. So domain will be equals to real number set minus the value 1. The eighth problem is f of x equals to square root of x square minus 25. This is x square minus 25 should be more than or it can be even 0. So x minus 5 into x plus 5 should be more than or equals to 0. Nothing but in the number line, if I take the values minus 5, 0, 5, it should be away from the minus 5 and 5 to infinity. The domain can be now minus infinity to minus 5. This can be closed interval because the values can be even equals to 0. So it can be even equals to minus 5. Union 5 to infinity. This is my domain. Next question is ninth one. F of x equals to square root of x minus step x. This is defined only when x minus step x should be more than or equals to 0. Step x is a function. It is also called as the greatest integer function. For example, if I take step of 2.5, it will convert this 2.5 into integer plus 2 here. Similarly, if I take minus 2.5, this will be minus 2 minus 1, that is minus 3. Step of 0 to 1. From 0 to 1, whatever the input we give, that will be 1. And from 1 point something to 2, this will be, sorry, this is closed interval 1 to open interval 2, this will be 1 and this will be 0 here. So x minus step x is defined. If I put x equals to 2.5, this will be 2.5 minus step of 2.5, nothing but 2.5 minus 2, which is more than or equals to 0. I can't put the input as negative values, because if I take minus 2.5 as my x value, minus 2.5 minus of minus 2.5, this will be minus 2.5 plus 3, so it's minus of plus 3, this is positive again. So whatever the input data I give, it is defined for this. So for 9th one, the domain is given as the entire real number set. 10th one is f of x equals to square root of mod x minus x. So it's reverse of this now. The step x minus x should be more than or equals to 0. So step x should be more than or equals to 0. So step x is more than or equals to x. This is true only for the positive values of x. Like in the previous example, if I take x equals to minus 3.2, then step x will be equals to minus 4. If I take x equals to 3.2, then step x will be 3. So step x is never more than or equal more than x. Step x can be equals to x only when x belongs to integer values. For all the integer values, step x behaves as x, where for all x belongs to z. So this is the condition we have. But for decimal numbers, step x is always less than x, for x belongs to real number minus z. So this condition is valid here because in the square root it can be equals to 0 when x belongs to integer values. So domain equals to integer values. For all the remaining values like the decimal numbers or the rational numbers, it is not defined because step x is always less than x. Second bit, first question. Find the range of following real valued functions for log of 4 minus x square. So given log of 4 minus x square, here this is mod of 4 minus x square. So it is always positive. The range will be, it can be any real number, because log of all the positive numbers gives all the real numbers. The output is always the real number. So range equals to any real number. Second one is square root of step x minus x. Now for this function, the domain is x belongs to integers, only integers. So range will be, range equals to always 0. For x belongs to z, step x will be equals to x. So the output is always 0. Third one is sine pi into step x by 1 plus step x whole square. That equals to, now whatever the input value we place here, the output is always 0 because Sine n pi is always equals to 0. This is always 0. So range equals to 0. Fourth one, x square minus 4 by x minus 2. This function is not defined for x does not equals to 2. So x should not be equals to 2. The domain is that x should not be equals to 2. And coming to range y equals to x square minus 4 by x minus 2, that equals to x minus 2 into x plus 2 by x minus 2, that equals to x plus 2. But y cannot be equals to 2 plus 2. For x belongs to 2, the function is not defined, so y does not equals to 4. So range equals to, subtract 4 from the real number set, r minus 4. This is the range. Fifth one is square root of 9 plus x square. The domain for this equals to, domain is always real number set. Whatever the value of x we have, it is defined, the function is defined. Coming to range, let y equals to 9 plus x square. So y square will be equals to 9 plus x square. That implies x equals to square root of y square minus 9. This y square minus 9 should be defined now. So y square minus 9 should be more than or equals to 0. Y minus 3 into y plus 3 should be more than or equals to 0. So if I draw the number line, this is 0, minus 3, 3. So 3 to infinity and minus 3 to minus infinity. So range equals to minus infinity to minus 3 union 3 to infinity. Some textbooks give the answer as 3 to infinity, but suppose if I take a value like x equals to 0, then y will be equals to root 9. Root 9 can be plus or minus 3. My output is either plus or minus. It can be either positive or negative. So even I can get the negative numbers as my range. So it is minus infinity to minus 3 union 3 to infinity. This is the correct answer. Third bit, given that f of x equals to 2x minus 1 and g of x equals to x square. First one is we need to find 3f minus 2g of x. This is equals to 3 into f of x minus 2 into g of x. That equals to 3 into f of x is 2x minus 1 minus 2 into g of x is x square. 6x minus 3 minus 2x square. This is the value. Second one is fg of x. This is nothing but f of x into g of x. It is a product of two functions, 2x minus 1 into x square. So this will be equals to 2x cube minus x square. Third one, root f by g of x. This can be written as root of f of x by g of x. That equals to root of 2x minus 1 by x square. Next one is fourth one. This is f plus g plus 2 of x. That equals to f of x plus g of x plus, this is not 2 of x, this is just 2. So it's a constant, it remains as it is. f of x plus g of x is 2x minus 1 plus x squared plus 2. That equals to x squared plus 2x plus 1. Nothing but x plus 1 whole square. Fourth bit, f equals to 1 comma 2 and this is 2 comma minus 3, 3 comma minus 1. First one we need to find 2f. Nothing but, so first I have f of 1 equals to 2, f of 2 equals to minus 3 and f of 3 equals to minus 1. 2 into f is nothing but 2 into f of 1, that equals to 2 into 2, which is 4, and 2 into f of 2 equals to 2 into minus 3, that equals to minus 6. 2 into f of 3 equals to 2 into minus 1, that is minus 2. So 2f will be equals to 1 comma 4, 2 comma minus 6 and 3 comma minus 2. Second one is we need to find 2 plus f. 2 plus f of 1 will be equals to 2 plus 2, that equals to 4, and 2 plus f of 2 will be equals to 2 plus minus 3, that equals to minus 1, and 2 plus f of 3 equals to 2 minus 1, that equals to 1. So 2 plus f can be written as 1 comma 4, 2 comma minus 1 and 3 comma 1. And the third one is f square, that equals to f of 1 whole square. F of 1 is, we have that f of 1 equals to 2, so this is 2 square, that equals to 4. F of 2 whole square equals to minus 3 whole square, that equals to 9. F of 3 whole square equals to minus 1 whole square, that equals to 1. So f square will be equals to 1 comma 4, 2 comma 9 and 3 comma 1. Fourth one is root f. So first is root of f of 1. Root of f of 1 equals to root 2, and root of f of 2 equals to root minus 3. Now we need to define this function only for the real values. So this is not defined. And similarly, square root of f of 3 equals to root minus 1. Even this is not defined. So only the output is root 2. So root f equals to 1 comma root 2.